Okay, perpendicular lines. On the Cartesian plane, there's a relationship between two lines that are perpendicular. So that's what we're talking about, perpendicular lines on a Cartesian plane. Perpendicular and the word normal, same thing. So these two lines are normal to each other or they're perpendicular to each other. They meet at a right angle, all the same thing. So the special thing there is the slope of the first one multiplied by the slope of the second one is -1. So that's your rule. So let's just, there's a pattern there. Let's just say the first line has a slope of 2. The slope that's perpendicular to it is -1/2. If it's 4, it's -1/4. If it's 7, it's -1/7, because when I multiply those two together, I get -1. What if the slope wasn't an integer, but it was 2/3? So what we do is we flip it. So we're thinking of 4 as 4/1, and we're flipping it to get our answer. So I'm going to flip it, and it's the negative of. And you can see that if I multiply them together, I'm going to get -1. What if my first given is actually negative to start with, -7 on 5? Then all I'm going to do is flip that upside down, and it's the negative of the negative, which is a positive. So that's perpendicular to that, because when I multiply them together, I get -1. Okay. Find the line that is at a normal to the line y equals 2x plus 1, and this line that I'm looking for goes through the point 2, 3. So, what's perpendicular to that? I'm looking at what's perpendicular to 2. Okay. So the line that I'm looking for is y equals mx plus c, and I know that that slope is perpendicular to 2. So perpendicular to 2 is that. I'm okay with that, and you're just going to go m1 times m2 equals -1. Therefore, I'm going to find c by subbing in a point. 2, 3. So when x is 2, y is 3. That is -1. So c equals 4. So what is the line that's at a normal to that? Would be y equals -1/2 x plus 4. Next. The following lines are perpendicular to each other, or the following lines are normal to each other. Same question. All I know is that one and that one are perpendicular, so therefore their slopes, I've got the rule m1 times m2 is -1. The slope of that green one is 2. 3y equals minus beta x plus 8. Let's rearrange it because I've got no idea what that slope is. Y equals minus beta on 3x plus. So I know that m2 is negative beta on 3. Beta is a Greek letter. Okay, so I'm going to use this rule and go 2, therefore 2 times negative beta on 3. That would be nice, wouldn't it? It's not negative beta on beta, it's negative beta on 3. And that must equal -1. So you can see the two negatives will cancel each other out. I'm going to leave the beta there. The 3 will go to the top and the 2 will go down the bottom. So beta is 1.5. These are just different ways of applying that rule. It's not rocket science. The rule is pretty easy. You've just got to be able to apply it in lots of different ways. I've just got 4 points there, and each point is a line. So, if I've got A, B, C, there's AB, and CD is perpendicular to it. Okay. So how do I find, and they're normal to each other, and I don't know what that K is. So I guess what I've got is the rule, M1 times M2 is -1. How do I find the slope of AB? Slope is rise over run, y2 minus y1, so let's go. So let's pick this as point 2, so y2 is going to be 3 minus 2 on k minus 1 multiplied by y2 y1, 7 minus 5 on x2 minus x1, and that equals -1. So really my knowledge of perpendicular lines is gone now. This is just turned into an equation. 3 minus 2 is multiplied by 7 and 5 is 2. 6 minus 4 is 2. So really, that's 1. I'm going to get that up to the other side. So 1 equals minus k plus 1. K equals 0. So there you go. If k is 0, those two lines are perpendicular. Done. Go have some fun.